Hey guys, welcome back to your AP Chemistry videos. This will be the first of a few videos that will cover basic chemical nomenclature. For this video, we are only going to be covering covalent and ionic, and then the next videos will touch on the more difficult types of ionics and then acids as well. Personally, I think covalent are the easiest to name. Once you are able to recognize a covalent compound, we'll hopefully be able to name them fairly quickly. So in order to recognize them, you need to know that they're composed of two nonmetals and they're bonded together through the sharing of electrons. The rules for naming them. First element is named using the element's name. Wow, that's hard. The second element is named as your typical anion would be named. So you would change the ending to IDE. And then the last rule is that you're going to use the prefixes to indicate the number of atoms present in each element, the only exception being that mono should never be used in front of that first element. Here's the prefixes that you need to know. Only needs to go up to 10 for us, mono through deca. If you know these prefixes, you're good. If you don't, then start getting used to them. This one is tricky. This one is tricky. And those are the two that usually trip people up the most because a lot of people think 4 as being quad, and then just a lot of people don't know 7 for whatever reason. 7 kind of is the ignored prefix of these. So make sure you know those and you'll have no problem with covalent compounds. Let's go through a couple examples here. First one, N2O. Well, we've got two nitrogens here. Remember the first element, we just use the name of that element. So it's going to be nitrogen. And then we have to attach a prefix at the start based on how many we have. So there's two nitrogens there. So we're going to attach the prefix di. And then we name the second element with a prefix as well, regardless of what that prefix is. So it's going to be dinitrogen monoxide. And we've named our first element mono 1, di 2, so we have two nitrogens and we have one oxygen. We changed our ending of oxygen to IDE like our rules told us, and we're good to go. Next example. Remember there was an exception for this first element. You never want to use the prefix mono for that first element, so we're not going to put mononitrogen. We're just going to write out nitrogen for this one. And then we name our second element, which is oxygen, change the ending to IDE, so it's going to be oxide, and we'll attach our prefix. There's only one of them, so it's going to be monoxide. Please do not write this. Right? If there's ever two vowels next to each other, sometimes you have to get rid of one of them so that we have the proper pronunciation. We don't want to have monoxide or monoxide. We just want one of these O's. So do not do this over here. It should be monoxide. Another example, NO2. We have one nitrogen at the front. So again, we don't use the prefix for that first element. So it's nitrogen. And then we do use a prefix for the second element. So it's going to be nitrogen dioxide. N2O5, both of these will require prefixes because both of them have a specific number of elements there. So it's going to be dinitrogen. And then our prefix for 5 is pentoxide. Again, the prefix on the last slide was penta. We don't want to have pentaoxide. We want to drop that A and make it pentoxide. And our last example here, a couple different elements. We've got phosphorus. We don't want to use mono. Phosphorus, because we don't use mono ever with that first element. And then we need penta for 5, pentachloride. And there we go. This is exactly how you should be naming all of your covalent compounds. So let's move on to our first type of ionic. Now, an ionic compound is going to be a positive cation that is combined with a negative anion. And you always write that first cation, or you always write the cation first and your anion second. And usually an ionic compound contains a metal plus a nonmetal. Let's take a look at our rules here for binary ionic compounds. Number 1, name the cation first and the anion second. Simple enough. Number 2, the cation is the name of the element. Just like with covalent, we just name that first element. And number 3, the anion is the name of the element, again changing to IDE, just like we did with covalent. So basically you name these the same way as covalent compounds, but you're not going to be using any prefixes. So don't ever attach mono or di or tri to an ionic compound. You just leave those off. Let's take a look at a few examples. NaCl. Our first rule tells us that we name the cation first, and that element would be, or the first one, the cation is the name of that element. So Na is going to be sodium. And then we're going to name our anion second and change the ending to IDE. So sodium chloride, which we all know as table salt. Our next example, Li3N. Well, let's name our first element. And remember, we don't need prefixes because this one is ionic. It's a metal and a non-metal. So we have lithium. And then our anion is nitrogen, so we want to change the ending to IDE. So it's going to be lithium nitride. Okay, and the last example that we're going to look at here is MgO. We'll name it magnesium for that first element there, magnesium. And then we change our ending to IDE, magnesium oxide. All right, now sometimes we do have to go in the reverse direction. So instead of having the formula and needing to give a name, sometimes you're given the name and you have to write a formula. So the first thing you want to do is determine the charge of the individual ions. And after that, you're going to write the formula so that the positive charges cancel out the negative charges. Let's take a look at a couple examples here. We have the name. So we know potassium is K. We know iodine is I. So there we go. We wrote our two elements. Now let's double check this second part right here. We want to double check that the positive charges cancels out the negative charges. If we take a look at our periodic table, potassium should have a charge of 1 plus, and iodine should have a charge of 1 minus. Right? Because of this, well, they cancel out. A plus 1 and a minus 1. They cancel out, so we don't need to change the number of elements that we have in our formula here. We only need 1 potassium and 1 iodine to cancel these charges out. So let's go on to another example. This time we've got calcium, which is Ca, and then we have sulfide, which is sulfur, and that's going to be S. Now, for calcium, we have a charge of 2 plus if you look at the periodic table. And for sulfur, you'd look at the periodic table and you'd see that it has a charge of 2 minus. In this case, you do not want to put Ca2S2. Right? You always want to simplify your formula. So instead of writing what we have right now, we're going to cancel those two out there, and we're going to put CaS as our formula. You always want the most simplified version of your formula. If you're able to cancel charges out, you should always do so and have that most simplified formula. Our last example we're going to take a look at here is aluminum oxide. So we've got Al and we have O. Right? Now I know based on the periodic table that aluminum has a charge of 3 plus and oxygen has a charge of 2 minus. In this case, our charges don't cancel out easily. So how do we get a 3 plus and a 2 minus to cancel out so that we have an overall charge of 0? The easiest way to do this is cross your charges. So if you take this 2 minus, and actually if you just take the 2 and use it as the subscript for aluminum, and write it down there, and then you cross this 3 over for the oxygen, and you make it Al2O3, this will cancel out your charges for you. It's called the crisscross rule. Now you want to be careful with this. You don't always want to use it, and eventually, once you get the hang of it, you don't really do this every time. You just kind of figure it out in your head, and you'll end up writing the formulas pretty quickly once you get the hang of this. But notice that you would have 2 aluminums. That means you'd have 2 3 pluses. So 3 plus and 3 plus would give you a total of 6 plus charge. And then you would have 3 oxygens. Each oxygen represents a charge of 2 minus. And if you have 3 2 minuses, that means you would have a total charge of 6 minus. So 6 plus and 6 minus, they cancel each other out, and you are left with Al2O3 as your correct formula. If you guys have any questions, let me know in class. I'd be glad to help you out. And I'll be uploading a couple more videos with the more complex ionic and then acid naming. Thanks, guys, and see you in class.